welcome back, Math Marvels. In this lesson, we're going to undo distribution. I'll show you what I mean in a second. Let's look at this problem. Write an equation that is equivalent to 32m plus 56mp using factorization. So we're going to write a brand new expression that will be exactly the same. It will just look different. So this is what we're going to do. We're going to find the prime factor of the terms and write a new expression with a parentheses. That's what I mean by undoing the distribution. We're going to add a parentheses and have a factor right in front. What we can see the two terms that are here. And we see that both terms have a coefficient in the front. And we can see a common variable. There's an m. But notice there is a difference between the m, 32m, and the 56m. So first things first, we're going to find the common factors for 32 and 56. There are two ways I can think about this for 7th graders. We can list all the factor pairs, so whether it's factor pairs, factor rainbows, and just making a list, somehow looking and finding the greatest common factor of two numbers. Or you can use a new skill that I will share called prime factorization to find the greatest common factor. Either one will work. Most kids will like option A, but there may be some who find value in option B. Then we're going to write the greatest common factor, including the variable m, because m is in both of those. I can divide both of those terms by m to pull out an m. And that will be the new term outside the parentheses. This may not make sense, so I want you to watch for this second part of my plan so you can see what that looks like if you're having trouble visualizing it right now. And then we're going to divide both our terms by our greatest common factor and write these new terms inside the parentheses. So it may not make a little sense yet, but it will in a few moments. So hit pause and jot this down into your notes. Okay, let's find these factors. We're going to use two ways. First one, let's look at just some factor pairs. So for 32, I know the easiest one is 1 times 32, 2 times 16. I'm going to skip 3 because that's not a factor. 4 is a factor. 4 times 8. I know 5 is not a factor. Is 6 a factor? No, it's close. 6 times 5 is 30. Is 7 a factor? No. So my next number would have been 8, which I already have. So I have all my factors here for 32. And I'm going to do the same thing for 56. And I start with the easiest. 1 times 56. And that is even, so I know there's a 2. 2 times 28. Is 3 a factor? No. And if you're not sure, like I use a little trick to see if things are a factor of 3, if the digits add up to 3, 6, 9. 5 plus 6, it does not add up to 3, 6, or 9. 5 plus 6 adds up to 11. So nope. So is 4 a factor? Ooh. 4 is a factor. 4 times 14. 5 is not a factor. Is 6 a factor? Nope. 6 times 9 is 54. So again, notice I'm just going up on these numbers. So I know 5 is not a factor. I know 6 is not a factor. Is 7 a factor? Yes, 7 times 8. And those are close. So I know I'm done. And now you just got to look and see, do they have anything in common? They both have a 1. They both have a 2. They both have a 4. They both have an 8. And that's it. So our greatest common factor equals 8. This means I can put an 8 on the outside of my parentheses. And I want you to think for a minute. So what does that mean for the 32? How many 8 times what makes 32? 4. So that's 4m. And then I'm going to do the same thing with the 56. This has an MP at the end. So 8. 8 times 7 makes 56. So this is how I use factorization to create an equivalent expression. So I just took my greatest common factor over here, 8. And all I did in my mind was I said, well, 32 divided by 8 would give me 4. That's why I got that number. And I did the same thing, 56 divided by 8 would give me 7. And I put that one there. So this is one way you can find common factors. I'm going to give you one more way. But if this was tough enough and you want to stay with this one, use this one. But I'm going to give you another one. If you're interested, keep going. And prime factorization means I'm going to keep breaking down this number. And I'm going to find every common factor. So I like to just think of any factor pair. Like, I don't have to start with the smallest one. For example, 32 I know is 8 times 4. And I keep breaking this up. So how do I get 8? Well, 4 times 2. And I can't break up 2 anymore. And I can break up 4 into 2 times 2. So these are the prime factors for 32. Okay, 2 times 2 times 2 times 2 times 2. And I'm going to do the same thing with 56. 7 times 8. I can't break up 8 anymore. I'm sorry, 7 anymore. I can break up 8 into 4 times 2 and 2 times 2. So prime factors of 56 are 7 times 2 times 2 times 2. Now here's the fun part, right? Watch this. What do they have in common? I'm going to write them on top of each other so you can see. Here's 32. Here's 56. And I'm going to look for what they have in common. So 32 is 2 times 2 times 2 times 2 times 2. 56 was 2 times 2 times 2 times 7. So what do they both have in common? It's kind of like go fish. Like when you get a pair. Well, I got a pair of 2s. So I put a 2 there. I got another pair of 2s. I put another 2 there. I got another pair of 2s. So I put another 2 there. And they don't have anything else in common because I only have 2s and 7. So the greatest common factor would be 2 times 2 times 2 or 8. So here's just another way of finding that common factor for the outside. It doesn't really matter which one you want to use, but I want to give you both options. So you have prime factorization as well as just using factor pairs. Hit pause so you can jot this down. Again, once you have your greatest common factor, it goes on the outside of parentheses and then you divide to figure out the terms on the inside. And here's our second problem. The directions are really short. Simplify the expression. So kind of hard to restate this another way, but basically we're going to distribute that negative sign. And there's something special about that we're going to make very, very clear and combine the like terms so we can simplify this entire expression. So that negative sign in front of the parentheses, we're going to learn to rewrite it as -1. So yes, we are subtracting that entire expression inside the 3x minus 2, but what we're going to do is we're going to rewrite it as -1 times 3x minus 2. So one, you're going to see me rewrite the expression, and then you're going to see me distribute the -1, and finally we're going to combine the like terms, and that will be how we simplify the expression. Hit pause and jot this down and we'll get to work. I love distributing, and when we see this negative on the outside, we're just going to put a -1 there and it's invisible. So the first terms are pretty easy. It's just going to be 7x minus 5, but let's distribute that -1. So what is -1 times 3x and -1 times -2? So just rewriting in front. -1 times 3x would just be -3x, and -1 times -2 would just be a +2. So that's our first step, was just to distribute. Now let's look for our like terms. Notice I am also highlighting the signs, the positive and negative signs, and I want things that are the same together. So my blues are next to each other, and my yellows are next to each other. Makes this easier. All right, I have 7 x's. I take 3 x's away. That leaves me with 4 x's. And I have -5 and I add 2. So that leaves me with -3. And I cannot simplify this anymore because they're different terms. One has a variable and one does not. So that's it for this one. Remember, if you have just a negative sign in front of your, just like this, a negative sign, when you see that, write it as -1 and distribute. And that's it for today's lesson, Math Marvel. We're going to do a lot more work with expressions and equations. Just keep practicing, ask questions, and I'll see you in the next lesson. Take care. Bye.